வீடியோ ஆன்ல இருக்காதுக்கா, நீங்க எப்பனாலும் போய்க்கலாம் வந்துக்கலாம், ஒன்றும் பிரச்சனை இல்லை. வீடியோ ஆன்ல இருக்காது, நீங்க எப்பனாலும் வரலாம் வந்துக்கலாம். ஓகே, நான் வாய்ஸ் மட்டும் ஸ்டார்ட் பண்றேன். Okay. So good evening everyone. So this is Saravanan, PMRF scholar of Department of Civil Engineering and IIT Tiruchirappalli. I am handling this course, wastewater treatment and recycling problem solving session of PMRF TA-ship for this July 2025 session. And the course instructor is Dr. Manoj Kumar Tiwari sir from IIT Kharagpur. Now he is in IIT Kanpur, associate professor, and I am allotted as a PMRF TA. I am from NIT Trichy, so as a part of PMRF deliverable, I am taking this course on every Monday 6 to 8 p.m. And this is the second week of our course, and it will be for 2 hours. And first 1 hour will be I am going to take the same lecture material what Sir has taught in the Swayam portal, and the second 1 hour we are going to discuss about the old assignment problem. So this is our regular schedule. And last week we have discussed about the first week module, that is what is wastewater treatment, and what is wastewater recycling, and what are the various sources and types of wastewater and need for wastewater treatment. That is what we have discussed in the last week. And the content for today is how much wastewater we are going to generate and how we are going to calculate the quantity of wastewater generated. That is the major thing we have to calculate on the first hand. Okay, so that's what today's content. So if you have any doubt in the meantime, you can ask now. In the meantime, some of others to join. We can. If you have any doubt in last week's assignment or something, you can ask now, or else we'll continue with today's session. Yeah. So you can unmute and you can ask, or in the parallel, you can also post it in the chat box. I'm happy to answer the questions. Um, Otherwise, let me start with this today's course content. Yeah. Is my screen visible?
Yes, sir.
Yeah. Yeah. So we'll start with today's lecture. Yeah. So this week we are going to discuss wastewater generation and quantity estimation. So in this, the wastewater generation sources we have discussed in the last week, that is municipal source, agricultural source, and the third one is stormwater or the industrial wastewaters. So these four categories we have discussed in the last week. So municipal is from the households as well as from commercial and institutional areas. Industries are from industrial effluents. Agricultural are runoffs, that is that have mostly organics, pesticides, and agrochemical waste that will be mixed with the agricultural runoff. The fourth category is stormwater, that's not considered as a wastewater, still it has lots of sediments along with that. That's what the four sources we have discussed earlier. So that characteristics will vary based on the source. And industrial effluent is considered as the most polluted type of wastewater, because domestic will have mostly the organics that can be easily degraded by biological treatment system in our sewage treatment plant. But industrial effluents will have different chemical properties that cannot be treated in our regular or conventional wastewater treatment plant. So we need a specific what we say combined or effluent treatment plant, that is called CETPs, combined effluent treatment plants. So we can have a CETP for a tannery, SIPCOTs, or textile industries. Combinedly, they can have a CETP that can handle the wastewater coming out of the specific industries. Okay, so the unsustainable management of this wastewater will cause a major that is our major challenges. So we have discussed what are the impacts. First is health impact, second one is environmental impact, third one is economic impact to the nation. These are all we have discussed in the last week. Once again, sorry. Hello sir. இல்லைங்க சார், மழை வருதுன்னு மறுபடியும் கேபின்லேயே உட்காந்துட்டாங்க சார். நான் இங்கே என்பிடி நான் இங்கே என்பிடிஎல் கிளாஸ் எடுத்துட்டு இருக்கேங்க சார். நான் ராஜு அங்கே தான் இருக்காங்க சார். ஓகேங்க சார். Sorry for that. Let me continue. Yeah. So the quantity estimation of wastewater depends on what are the type of the industry or what is the production capacity of the industry. So if it is a textile industry or a sugar industry, it will have a different type of wastewater. If it is a 100 hectares industry or a 500 hectares, based on the area or based on the capacity of production per day's capacity, the quantity will vary. And the agricultural runoff quantity depends on what is the type of crop we are cultivating, or the cropping pattern, or the irrigation supply, or the precipitation. So that will also, because the runoff is majorly based on how much rainfall happening in the agricultural area. So precipitation plays a major role. Agricultural wastewater is considered as a non-point source. What is non-point source? We can't find the source, then it is called a non-point source, right? And municipal wastewater quantity based on how much people are living in the household and what is the water use pattern. Because some urban area, if you compare the urban and rural population, who will produce more wastewater? The urban people, because rural people may not have access to much amount of water. So the quantity of wastewater is directly proportional to how much water we are supplying, right? So urban area are consuming lots of water, so they are producing lots of wastewater. So that is the direct relation. Also based on how much cost we are paying for the water, that is the water tax or metering. Water meter, some cities or metro cities are having water pricing based on the meters. So that will also reduce the consumption, that will also reduce the quantity of wastewater generation, right? So that are all factors that affects the quantity of wastewater generated, and also based on the standard guidelines. So we have a CPHEO guidelines to be followed to design the sewage quantity or STP's quantity, how much we are getting, that we are going to design based on these three factors. Okay. So why we need to estimate first? Because we need to design a sewage and a stormwater drains, and that design is directly based on how much water that is going to be generated. If we are overestimating, then our sewer design is uneconomical, because we are building a bigger sewers. If we are underestimating, then we can't accommodate all the wastewater that is coming in, right? So both overestimation and underestimation will have an impact. One is uneconomical, one will be inadequate design, right? So if the also we have to design based on the design period. So if you are given with a city, say for example I am designing for Chennai, the stormwater drains or a sewage lines. So I have to design the sewer line to accommodate the wastewater that is going to be generated for next 15 years, because the life of the sewer line will be for at least 15 years. So we are also going to study the design period for different components of sewers. So sewer lines may be at least for 15 years it's going to sustain. So I need to calculate how much population will be there for next 15 years. I have to design for that design population, right? Then only my sewer can accommodate the waste that is going to be generated after 15 years also. So design period of the sewers include future years. So that need to be a population need to be forecasted for the design period. Then only it's a proper engineered design of a sewer. So we need to know the population. We need then only we can estimate the quantity of the sewer sewage that is going to be generated. Then only we can design the sewer. So this is the direct relation. Yeah. So we can design two types of sewer. One is separate sewers, combined sewers. What is separated sewer? We have to accommodate two wastewaters. One is sewage, another one is storm water. Storm water will come only when the rainfall happens, that is in the monsoon season. And the other one is sewage, that will be going to be generated every year from the households or from the industries or any commercial, municipal, industrial sectors. So I have to handle two types of wastewater. One is sewage, another one is storm water. But in the dry weather, only the sewage will come. But in the wet weather, both the sewage and the storm will come. So if we are handling both in a same sewer line, then it is called a combined sewer. If we have two separate sewer line, one is for the sewage, one is for the storm water, then it is called a separated sewer line. You got the difference, right? So in this, if you see, during dry weather, only in the bigger pipe, the sewage alone will come and it will be uh, directed towards the sewage treatment plant. But in the wet weather, sewage also will come and also the rainwater runoff, that is the storm water, will also mix and it will go to the STP, and the overflow, that is the maximum quantity, I mean the excess quantity will be redirected to the bay or any marine discharge. But if you are designing a separated sewer, only during both dry and wet weathers, a sewage will be carried in the sewer pipe, and the stormwater drain will be ideal during the dry weather, but during wet weather it will take only the stormwater and it will be discharged into the marines. You got the difference, right? So if you see in the dry season, the dry weather flow is considered as your sewage quantity, because that is your only sewage will come, that is called the sewage quantity, that is the dry weather flow, DWF. And it is based on the water used, type of area served, weather condition, and infiltration in the sewer. These are the four factors that will affect your dry weather flow. Dry weather flow is nothing but the sewage quantity. Okay. So the fluctuation is also based on the pattern of water consumption. That is what I have said, based on urban or rural, and fluctuation in the dry weather flow. So what are the components we need to consider before estimating the quantity of the sewage? First, what is the water that is discharged from the households? What is the industrial effluent? What is the discharge from the public places? From the private water supplies, because some people may rely on private water supplies also, and the entry of rainwater or groundwater through the leaks. So that is another major component we have to consider. First is water discharge from the household, that is our sewage. Second one, industry effluents will also come, that is an added one. So we have to have first one is sewage, second one is industrial wastewater, third one is discharge from the public places, fourth one is private water supplies, because not only the water that is supplied by the municipality, we are also having some bore wells, so that will also give some water, so that will also come out along with the wastewater. So private water supplies and entry of rainwater and groundwaters into the sewers, so through the leaks. So this all contribute to our sewage. Okay. So what are the steps to estimate the sewage? First is we need to know the design period, how much year it's going to serve for the city or municipality, and then design population. If I know 15 years, then what will be the population after 15 years? That design population I need to forecast. Third one is per capita waste generation. If I know there will be 1,000 people today, and after 15 years there will be 2,500 people, and what is their per capita generation? Per person will generate this much quantity. Example, 135 liter per capita per day. So that is our standard. Okay. So this much liters a person will generate per day. Liter per capita per day. You understood? That is the unit of the wastewater generation. So this is the water supply we are doing based on the codal provision. So out of this, around 80% will come out as wastewater. And then peak flow I need to know. That is the flow I need to design the sewers. If I calculate like 150 MLD or million liter per day, that is MLD, then I should not design exactly for 150. I have to consider the peak condition. Then I have to multiply a peak factor like 1.5. That is a factor of safety, I can say. So I have to get the peak flow and then additional inflows. Not only the sewage, additional inflow that we have discussed in the last slide, that also I have to consider. Finally, the cumulative design I need to know. So, how to design the total wastewater generated? I need to know the population, I need to know the per capita, and I have to multiply with the peak factor. So, if I know the 1,000 people and one people is generating 135 liters per day, and I have to know the peak factor or factor of safety as 2 or 1.5. So, that is the total wastewater generated plus some additional wastewater will also come. Totally, a cumulative factor I have to multiply. Okay, so this is the total quantity of wastewater that is going to be carried by my sewer. So I have to design the sewer for this quantity. You got it? So this is the total steps I have to follow. What is the first step? Design period. No, that's what I am going to discuss in this slide. What is the basis to consider 15 years? That's the question, right? So here I will say, I am saying 15 years as an example for sewer lines. Here you can understand clearly. What is the point in fixing the design period? So we have a manual called CPHEO, Central Public Health Engineering Organization. So that recommends a design period of various sewage components. I am talking about the sewer lines, right? So sewer lines are whatever the main pipes will have 15 years as a design period. You can see the guidelines. So this is given by CPHEO 2012. This guidelines also I will upload in the as a reading material in the Google Sheet. I think you all could access the Google Sheet right nowadays. Let me show you once again how to access the sheet. So if you go with this, so as I said last week, you can see the problem solving section here. So we have a third week session uploaded now, and below that you can find the problem solving session July 2025. In that you can see the problem solving session recordings. So here I have uploaded my last week's recording. Here you can see my name Saravanan, and parallelly two more PMRF scholars are also taking on Saturdays and Tuesdays. So I am taking on Monday 6 to 8. So here you can find my first week lecture video, and also I have uploaded all the material in this Google Drive. So if you go to the Google Drive, my lecture material what I have taught in the last class, and if you come with the problem solving, the questions I have solved in the last week, and some of the reading materials also I have uploaded, like the EPA standard we have discussed, eutrophication we have discussed, and the Ramsar convention sites and all I have given in the Word file. So this also you can refer. So today I will upload the CPHEO manual. Okay, you can also access the Google Drive link. So the design period for different sewage components are given by the CPHEO manual. So we have to refer that manual. So the land should be acquisitioned for 30 years. The conventional sewer lines are designed for 30 years, and the non-conventional sewers are for 15 years. Pumps, I have to design the main pump for 15 years, and civil works for 30 years. Machineries I have to consider for 15 years, because in the economic calculation of the pump also I have to design uh, what we say calculate the depreciation value for 15 years, so that I can buy a new pump in the next 15 years, right? So that also will be coming in the environmental economics. So sewage treatment plant I have to design for 15 years, effluent disposal for 13 years, and effluent utilization for 15 years, that may vary with the case. So I am considering as an average 15 years for the sewage lines. So that is the period, or you can refer any of these standard codes to design. So this is given in our Indian condition CPHEO manual. So first step is over. We know the design period. Then we have to calculate the population of the design period. So I know the today's population. But how can I calculate the population of 15 after 15 years population? How can I calculate? So we have different methods to calculate the population. So that's what we are going to discuss in the next 10 slides. So what is the factor that will affect the population change? Some people may born, some people may die, and some migration may happen. People will come from different cities to this city, and some annexation will happen, causes an increase. So future population will be current population if I take Trichy, we have 10 lakh population, say for example, and in 15 years, some birth may happen. Some 5,000 people may born, and 10,000 people may die, and some migration of plus or minus. If somebody comes, we have to add. Somebody left, we have to subtract. So this is the total formula behind the future population calculation. But we can't directly calculate. We have different engineering techniques to calculate the population or forecasting. That is called forecasting, population forecasting methods. So we have 10 different methods. First is arithmetic, second one is geometrical increase method, third incremental increase, logistical curve method, growth composition analysis method, master plan, decreasing rate of growth method, simple graphical, comparative graphical method, and ratio method. So we are going to discuss each of these methods in the upcoming slides. So when to use which method, that we are going to discuss. Okay. So if your city is a developed city, okay, like Chennai, if you take, that is already a developed city, no more population is going to come. A small increase will happen. So I can take arithmetic increase method. If you take a developing city, now only it started developing, then you can take geometric increase method. Or if the increasing rate may increase or decrease, then you can take incremental increase method. And some this other methods will vary based on the growth of the city. So that also I will going to discuss here. So first, if you take arithmetic increase method, the population increase at a rate, a constant rate. If you see, this is your constant rate. So I know the population today, 2025, or if you take 2010, 2020, 2030, 2040. So all rate will be constant. So dp by dt will be constant. Then you can take this method. Okay. I know the slope, though I can easily calculate. So every 10 years or every decade, the growth rate is 10,000 or 1,000. Then I can simply add by number of years, right? Number of decades. So it will be suitable only for large and established cities. So it gives lower population estimate. But if you take geometric increase method, it will give higher population estimate. That is overestimate. This will underestimate. Yeah. So how to calculate? See, for example, 1961, 71, 81 populations are given. I can take the difference of this population and I can take the average of this. That will be my um, average of one decade, right? So if you take the value, 75,301 is my average increase per decade. So they are asking the population of 2010. So I know the population of 2001 plus this average will give my 2010's population, right? So every decade, so 61, 71 is one decade. So 2001 is one decade and 2011 is next decade. But they are asking for 2010. So 0.9 is my decade. You got it. So if you know if you want the population of 2011, you can directly add. If you want the population of 2011, you can multiply with the 0.9 and you can add, right? So you can refer this. This is a network for gang water supply project. So they have calculated the population based on the arithmetic increase method, and they have also used the geometric increase method, and they have identified which is best fit. So percentage growth rate is constant means, so there the growth rate is constant. Here the percentage growth rate is constant. The growth rate itself increasing in a increasing order. Then you have to follow the geometric increase method. Here the simple geometric multiplication you have to use. There the population equal to sorry. So that the population equal to the current population plus the increase into t, right? The time, that is number of decades. Here the population at any time equal to the current population into 1 plus k by 100 power t. So this is the rate we are going to find. So how to find that? This don't think this is some of more mathematical. This simple what we say aptitude questions kind of thing. So here you have to use this only for new cities which is having unlimited scope of expansion. So like for example, if you take newly developing cities like Trichy is also fully established. Some cities that is growing like Coimbatore and all, if you take, that are all relatively new cities that is have unlimited scope of expansion, then you can use this geometric increase method. Okay. So if you take 1971 to 61, the population is this much. 1981 to 71, So you can, same example only they have given 91, 61, 71, 81. This is the population increase. So they are finding the increase of this difference that is same here, and you have to divide 6460 with 6848. Then you can find how much percentage that is increased. So that is what they have given. Percentage is 0.94, 1.76 percentage, 0.58, 0.41. So that and all, if you take the arithmetic average, so there you have taken arithmetic average, here you have to take geometric average, like multiplying everything power 1 by 4. So there you are getting the k value. So that k value you have to substitute for in this formula, you will get the geometric increase method. Then incremental increase method. Here, how much increase in the increase? That's what the incremental increase method. So there may be some increase or some decrease in the increased value. So the same example they have given here. You say the 61 to 71, 81 population only they have given, and same increase I have identified, but the increase in the increase or decrease in the increase I am finding. So 6,000 to 23,000 you have, see 16,000 increase in the increase we have, and of this to this we have a decrease in 1900. From this to this we have an increase in 2400. So how much average increase in the increase? So that is 17,000 is our average. So average if we take, sorry, 5,816 is my average increase in the increase. So same arithmetic mean formula I am using. See, P naught plus KT I am using, plus the incremental increase also I am adding. Okay, because the simply this will not give my total increase. Also, there is an increase in the increase, that also I have to consider. Or if there is a decrease in the increase, that also I have to consider. So that's why t into t plus 1 by 2 into I is given. I is what we are calculating here, the average in the increase. You got it? If I do some problem, you can easily understand this. Yeah. So fourth method is logistical growth method. I hope you all understood this three method: arithmetic, geometric, and incremental increase method. So I have discussed with the same problem here. So if you can't understand, I will just do the problem again if you want. So can I do it again or can I move forward? If people are clear with this?
Again,
Yeah, let me tell you. So let me take a new example, then it will be easier. Yeah. So the Trichy's population I am saying. So Trichy's population of 1950, 1960, 1970. So every decade. So here we are taking n as one decade. We should not consider years. We have to take every time decade. Okay, 1980. So this is the four value. So 1950 the population is 1000. 1960 the population is 2000. I'm saying for example. Then 3000. Then 4000. So this is the population increase every. I mean every year's population I know exact population. I need to calculate the population of 2025. So that data I don't know. So how to find? So I have the actual population of this many years. So first I am using arithmetic increase method. So this is the population, this is the year. So I need to know what is the difference in the population, that is the increase. How much increased? See 1000 to 2000 there is a 1000 increase. 2000 to 3000 there is a 1000 increase. Right? This minus this I am calculating. Then 3000 to 2000, and then 4000 to 3000 again there is a 1000 increase. Right? So what is the average of this 3000 plus 1000 plus 1000, 3000 by 3, you are getting the average of 1000. So this is the average increase in every decade. So I need to know 2025's population. So 1980 to 2025, how many decades are there? 1919, 2000, 2010, 2020, 25. So 4.5 decades are there, right? Are you with me? So there are
yes,
4.5
sir.
decades.
Yes, sir.
Right? There are 4.5 decades. So if you multiply 4.5 into 1000, we are getting 4500. Okay. So after 1980, for 4000 plus there is a 4.5 decades of 1000 increase. So 4000 plus 4500 will give you 8500. That is the population of 2025. So this is based on arithmetic method. So if you need to know by geometric increase method, you need to calculate what is the percentage increase, not only the simple increase, you need to know the percentage increase. So 1000 by 2000 will be, sorry, this by this you have to calculate every time. this by this, this by this. So 1000 by 1000, 1. 1000 by 2000, 1 by 2. 1000 by 3000, 1 by 3. That is 0.5, right? 0.5. This is 0.33. So what is the average of this? Not the actual average, geometric average you have to take. So 1 into 0.5 into 0.33 power 1 by 3. So that is the geometric average. This is arithmetic average. Simply adding all and divided by the total number. This is geometric average. Multiplying all power 1 by that number. Okay. So 1 into 0.5 into 0.33, how much? You take the calculator and do 1 into 0.5 into 0.33 is 1.165 power 1 by 3 will give you 0.5. Again, the answer is 0.5. 0.54. Okay, that much percentage increase in every year. So how much again the difference in the decade? 4.5 is the difference in the decade. So I know the formula. Arithmetic formula is P at any time equal to P naught plus our this value K into this T, right? That's what we have. But in the geometric method, Pt equal to P naught into 1 plus K by 100 power T. That is simple interest formula only. So we know the population of this year, that is 4000 into, I need to know the population of 2025. So that T is 4.5. That is a decade. Okay. K is what we have found, 0.54. So 0.54 by, already we have given in point only. So 54% or 0.54 plus 1 power 4.5 into 4500. You will get 30,000. So see, what is the answer in the arithmetic? 8,500. But what is the answer in the geometric? 30,081. See the great increase, right? So that is the increment overestimate. This is underestimation. But if you see the incremental increase method, every year there is 1,000 increase. But how much increase between every year? So the increase in the increase is 0. Here also 0. There is no much increase within the years. So the answer is directly equal to the arithmetic increase method. So you are clear with this?
Yes, sir. Thank you, sir.
Yeah. If you have there is a change in this value, then you will get a value for I. So that also you have to take care along with the arithmetic increase method. So 1 plus this formula you have to use t into t plus 1 by 2 into I. Same arithmetic plus this value. It's so simple. Simply like what we say, interest calculation. Yeah. Then these are all theoretical methods only, like logistical growth method. So this method will be applicable where there is a saturation limit of population. So you don't have a city which have unlimited scope for expansion. We have only limited scope of expansion. Then this method can be useful, like logistical growth method. So if you see a city will follow a specific curve pattern, like S pattern, that is called a logistical. In any city there is taking some lag time, then suddenly it will increase the population. Yeah. So that suddenly the population will increase, that is exponential growth. Then again there is a saturated population, like if you take Chennai, earlier it was low, then suddenly it increased in last 2-3 decades. Again now it is a saturated population, that is not much, but there is an increase but not much increase, that is called a saturation, right? So up to here there is a lag phase, up to here there is an exponential phase, up to here there is a saturation phase. This logical method we are forming means that is a logistic growth method, when the growth rate of the population due to birth, death, and migration takes place in a normal situation, and the population flow, the growth curve characteristics of the living population, like a shaped curve, it will be suitable for saturation limit of population, applicable for very large city with sufficient geometric data. Then you can use this method. Okay, the population carrying capacity of the city is limited. You can't hold 10 lakh 20 lakh population. The city have a population limit of 10 lakh only. You can't accommodate more than that. Then this method can be useful. Okay, so earlier rapid growth, then the growth rate becomes slower, and there is a growth rate becomes 0 at a saturated point. So you can use this formula. Formula will not be asked in any question, but please remember there is a formula to calculate based on the logistic growth method. And the fourth method is growth composition analysis or demographic method. Here we know the birth rate and death rate and the migration rate. If you know all this rate, then you can multiply in the formula. As I mentioned in the first slide, the basic slide, population we know plus birth rate minus death rate plus migration rate. Then you can find the population at this time. That is the demographic. For this, we need to know all the data for last this decades. Then we can find this method. And zoning or master plan method is useful when we have a city which have different zones. Like some are for residents, some are for commercial, some are forest area, some are public places, some are like recreational places. So only the population will grow in the residential area, right? Some are industrial area, means we have to calculate the population expansion only in the residential zone. So that master plan, if you know for a city, then we can estimate the population or forecast the population based on the master plan method. So here, if it is only useful when the city is newly going to be established, like I am going to design with the master plan, then I can use this method. So planned, regulated by the local bodies with the master plan, we can use this method. Population densities are fixed because here the population density is fixed, right? I know how many people are going to accommodate in a given area. For a hectare, how many population density, if I know. How to know the population density, that also we are going to discuss. Then graphical method. So graphical method is useful when we know, when we have a proper growth rate. See, I have 20, 90, 50 population, 90, 60, 90, 70, 90, 80, 90, 90, 2000 population. I know the growth pattern, right? It's going in this manner. So if I extend the growth curve, I can find 2025 value, right? So if the growth is going like this, then I know after this, it's again going to like this only, right? This is expansion, simple graphical method. Comparative graphical method is, if I know a city similar to my city, like if I am going to design for Chennai, I can take different metro cities like Kolkata, um, Delhi, Bangalore, Hyderabad. So all are going in this pattern, right? All are going in this pattern. So Chennai is coming, if I take different color, Chennai is coming like this and finishing here. So I need to know the future population. So these are all population of different cities that is in the history. So Chennai is like this. So again, it's going to follow the same trend like the other metro cities. So I can calculate the population by comparing with the different cities having the same characteristics, like metro city or any industrial similarity is there. Then I can compare with the same type of city. That is called comparison graphical method, right? Then ratio method. Ratio method is applicable when your city is having the same growth rate similar to our nation's growth rate. So there is a what we say, our India having a census data. If the city wants to know the population forecast for the next year, so I can compare with the nation's growth rate. So nation is having this trend, my city is having this trend, so I can know the ratio of like India's population by city's population in 2010 is 0.5. Then India's population at 2025, if I know, I can find the city's population at 2025 with the same factor 0.5, right? So this is, for example, I'm saying. So this is called the ratio method. For any bigger city, I can take the subcomponent of that municipality and I can use this method. But it's called ratios method. Then decreased rate of growth method. Whenever there is a city having a population growth get decreased, I can use the decreased rate of growth method. I can subtract the growth rate. The growth is not going to growth is going to decrease, but not the population is going to decrease. Yeah, you got it. So we understood the design period for different components, and we know the design population. If I know I am going to design for 15 years, and after 15 years I know how to calculate the population based on arithmetic, geometric, incremental, logistical method, or any graphical method. I know the population. So if I know the population into design period, I know next is I need to know the per capita sewage generation. So do you have any doubt up to this design population calculation? Can I move forward?
Yes, sir.
Yeah. So next we need to know how much a person is going to generate. I know the population is 1 lakh in 2025. So if I know how much a person is generating the wastewater, then I can multiply the population and I can get the total sewage. How to calculate the per capita waste generation? Based on the population density. how to found the population density? We know the floor space index or floor area ratio, that is a factor, FAR or FSI, that is given in the CPHEO manual again in 2012. So that is the permitted floor space index. If the population is up to 5,000, the density is 75 to 150 per hectare. Per hectare, there will be, we can accommodate 150%. Per hectare, we can accommodate 150 to 250% if the population is 5,000 to 20,000. So for cities like metro cities, for above population of 1 lakh, we can take the floor ratios 350 to 1,000 people per hectare. That is the population density, right? So see, again, the population density can also be calculated by subtracting with the other expansions. Like if you have road of 20, a city with 20% of its area covered by road alone, and 15% of its area covered by gardens, and 5% with the schools, and 2% with the market, and 2% with the hospitals and dispensaries. So total area is 100%, and subtracting all these amenities, you are getting a value, right? So total is 44. If I subtract with 100, I am getting 56%. So other this 56% is my residential area. You understood? So that is the master plan. So in this master plan, after subtracting all the other amenities, what is the area for the residential population, that alone I have to take, and I know the area of this city, for example 1,000 hectares or 10,000 hectares, and I know the percentage of that. Out of 10,000, 56% is residential. So for 5,600 hectares I am going to take. In 5,600 hectares, what is the population density based on the floor area? Take 0.5 as a assuming FSI as 0.5 and floor area as 9 meter square per person. I can take the value of number of persons is 311. That is the population calculation. Number of person per hectare I can understand. Okay. Yeah. Then per capita sewage generation. So as I mentioned, how much water consumed is directly proportional to how much water, wastewater, that is going to be generated. And there may be some leakages based on the evaporation, seepage, leakage. And arid zone, 40% of the water consumed will be coming as wastewater. But in a well-developed area, 90% is coming as again wastewater. So we are not, whatever we are consuming, that will not be staying in the system, or it's called mass balance. So people are considered as a system. Whatever the water going in, only 10% is taken. Another 90% will be coming out as wastewater. So 100% if you are going in. So that is called a system mass balance. So in a well-developed city, if you take, only 10% will be consumed. But in an arid zone, 40% will be consumed and only 60% is coming out as wastewater. And conventional sewers shall design for minimum sewage flow of 100 liters per day. That is a small value you have to take care. So any sewer, if your value is 90 liters per capita per day, you have to take a minimum value of 100 liter per capita per day or higher value. So that is your minimum value you have to design the sewer. Then only the self-scoring velocity of the sewer will be maintained. You understand? Otherwise, the sewer will not accommodate the. This is the minimum flow you have to consider. Yeah. Then the peak flow estimation. So the fourth point is peak flow. First is design period. Second one is population. If you know the population, you can multiply with the per capita. Then you have to multiply with the peak factor, right? So what is the peak factor? Every time the average value you should not take. You have to take the peak factor. Otherwise, you can't accommodate the sewer. Because if you take, I am designing the sewer for the average of 100 liter per capita, 100 liters per day. Then if suddenly a festival comes, people are generating 200 liters per day. How can I accommodate in my sewer? So that also I have to consider. In a peak time, say morning 6 to 8, people are using more water for bathing, for flushing, for everything, washing. So that time suddenly 500 liters per day are coming. Then I have to accommodate that 500 liters. And afternoon there won't be much water. Again in the evenings like 6 to 9, again water flow will be higher, 250 liters per day. So I have to consider the whole fluctuation in a day, and I have to take the peak value. So I have to design the sewer for the peak value to accommodate the wastewater, right? So if I take the peak value, that will be my, so this is hourly peak, or you can take a daily peak, that also you can take, right? So the sewage flow varies with hour to hour, season to season, Like monsoon season, there will be higher flow due to precipitation. Um, Summer season there will be a less flow, or summer season people may take more bathing, that time again peak flow will come, and festival seasons peak flow will be occur. So it will vary based on hour to hour, season to season, month to month, that and all we have to take into consideration. So the peak factor can be calculated like based on the population. Again, peak factors are given. Usually the thumb rule is maximum daily flow is average annual daily flow into 2. Average daily flow, if you know, you have to multiply with 2 to get the maximum daily flow. If you want to know the maximum hourly flow, you have to multiply the maximum daily with 1.5. So maximum daily is average daily into 2 into 1.5, you will get 3. So this is the basic thumb rule you have to remember. So if you know the average daily per day, I know the average daily value. I want the maximum daily. Maximum daily is average daily into 2. So if I want maximum hourly, maximum daily into 1.5. Or you can take the same substitution here, and I can use average daily into 5 into 3. Sorry, 3, because 2 into 1.5 is 3. So I only know the average daily value, so I can. So the receiver should be designed for maximum hourly. That's what I am going to say. And minimum value is 1 by 3 or 1 by 2 of average flow. That's what we are going to decide. Yeah. Then after knowing the what is our basic formula? Total quantity equal to population into design population. Okay, design population into per capita waste generation into peak factor. This is what we are going to discuss. Plus, additionally, there will be some flow, right? So that's what we are going to see here. Additional inflows. So where are the additional flows are coming in? Due to infiltration. So there will be some groundwater infiltration may happen into the sewer in which condition depends on the soil permeability, difficulty to estimate the infiltration. So we have to take a random value. We don't know how much leak will be there. So if the groundwater infiltration, you can directly take the value from this table. Per hectare, you can take this much liters. Or per kilometer of sewer, you can take this many liter. Or per manhole, you can take this much. Because the sewer is going to come and it is going to put it in the manhole and it is taken to the next sewer line, right? So per number of manholes also you can take for infiltration, or how much kilometer the sewer lines are running, you can take this value, or how much area it's covering, you can take this value. So if I know the area of the city, I can take any of this value between this 5,000 to 50,000 and I can multiply with my hectare. I'll get liter per day of infiltration. So I can add with this value. This many liters per day is coming. Already this is having some liters per day. So I can add this liters per day. Right? So otherwise I know 10 kilometers of sewer. I can multiply with this value, any one of this value, and I can take the liters per day. You got it? So this is the inflow and outflow, additional inflow and outflow. One is groundwater infiltration. Second one is some commercial institution may also give water. Not only the population. Here what we have calculated, only the municipal population. We didn't take into account any institution like schools, colleges, hospitals, markets, public park, that and all we didn't take into consideration, right? So that we have to consider here. Again, based on the CPHEO manual 2012, we have different institution and their water supply. So water supply, if we know the wastewater generated also, right? So hospital with bed exceeding 100, we have 450 liters per day of water supply. Hospital without 100, not more than 100 beds, 340 liters per day per bed. So large and house 180. Minimum amount will be for offices, day schools and all. We are using minimum liter like 45 liter per person per day. If it is a 10,000 population in NIT, we are having 7,000 students and it's a residential campus. So we are having total 10,000 population. So if you take 45 into 10,000, we know how much water supply. Right? Factories, cinema, concert and all, only 15. We are not going to stay much of time in that, right? So that's a recreational activity. So only 15 liter per day is enough. In restaurant, if you take 70 per seat, because we need to wash the utensils and all. Airport and seaport again 70. Public places 70. Like that, we have to note down the commercial institution inflow. along with the municipal waste. Third one is unaccounted private water supply. First one is infiltration, second one is institutions, third one is unaccounted private water supply. Like not only the water that I am supplying to the household, the people are also digging some water from the groundwater, and also they are taking from the nearby wells and they are using, and after use it is coming along with the wastewater that I am supplying. So I am supplying only 135 liters per day, and they are taking from the well or the bore well again 100 liter per day. So totally I am getting 235 liter per day as a sewage, right? So that also I have to take into consideration for design of the sewer. I should not design only for the 135 liter, then my sewer will fail to carry. So tube well, river, lakes, ponds, private bores, that also people are taking water, that I have to consider. And few industries may have some their own private sources. They will take from the lorry or some tankers. They also procure some water, that also I need to take it. And estimated through field survey and observation, I can calculate and I can account for the calculation. And losses, if I these are all additions what we are talking about, from institutions, from private households. And then third one is from infiltrations. Fourth one is subtractant, like losses. Some people may use the water for gardening, horticulture, air coolers, that will not come out in my sewer. And some people may use for road sprinkling, leakage in the distribution line, house connections. That also I can calculate by some field survey, and I have to subtract with my sewer line design. So that will be totally taken care in my sewer calculation. You understand? First is I have calculated the population. I know the design period. For the design period, I have taken the population, and I know the per capita generation based on the area, and I know the peak factor. So totally, I know the wastewater generated, plus I know the additional inflows from infiltration institutions and this type of public utilization, minus some of the leakages. So if I know the total design quantity, right? So finally, for Indian condition, you know the wastewater generation and treatment. Totally, we have 61 million liters per day of sewage that is generated. Out of which only 22,000 is we have the sewage treatment capacity. So we are treating. Remaining 38,000, that is around 60% or 62% is untreated wastewater that is directly discharged into the nearby water bodies. This is the statistics of our Indian subcontinent. So if you take 5 states like Maharashtra, Tamil Nadu, UP, Delhi, and Gujarat are accounting for, out of the 61,000, 50% of the total sewage are generated by this major 5 cities having major population. So they are generating larger sewage quantity. But Maharashtra alone generating 13% of the total sewage. But if you take the treatment capacity, we are lagging. Out of 60% only, sorry, 40% only we are treating, 60% we are letting out into the water bodies. So we have to enhance the treatment facility, and we have to have a extra capacity of sewage treatment plants. So this is the total representation. See, 67% of the total sewage treatment capacity installed in the India only in Maharashtra, Gujarat, Delhi, UP, and Gujarat having 67% of treatment system. Other 33 are in the other states, and no sewage treatment plant has been, especially in 7 states like this. These are all states still lagging sewage treatment plant. It is around 2018 data, and now they may have some treatment facilities. And capacity of STPs installed in 2 states like Himachal and Sikkim is adequate to treat the total sewage of these states. So we need to know how much treatment capacity of different states, and we have to accommodate all this wastewater, divert this wastewater to their STPs. That may be difficult. So we need to have this is what decentralized systems we need to design for the separate states, and we have to handle this remaining 60% to be treated in place. So if you take some of the problems in the class itself, they have some problems solved. So if you take the average and maximum hourly flow of sewages, let me hide this. So yeah, so average and maximum hourly flow of a sewage for a community of 1,000 person. So they have the population as 1,000, 10,000. That is the given data. And average hourly flow, average hourly estimation we need to know. and maximum hourly they are asking us to estimate. So this is all to find data. And average water consumption is per capita generation is 200 LPCD, right? And 80% of water consumption goes to the sewer. So if you multiply 10,000 into 200, we know how much liter per day. How much? 200 into 4 zeros. This much liter per day is water consumption. Out of this, 80% is coming, 80 by 100 is coming as sewer. So out of this 80% is coming as sewer. So we can change it in million liters per day or meter cube per hour. This is liter. So 1000 liters is only meter cube. So options are given in meter cube. So we can change liters to meter cube. So if you divide by 1000, so we will get 2000 meter cube per day out of this 80%. So 0.8. Multiply 8, 16, how much it is? 1600 is our average hourly flow. Because they are asking average water consumption. So we can get the average hourly flow. If you know the maximum hourly flow, what is the formula? Average hourly flow into 1.5 into 2, that is 3. That is our average maximum hourly flow. You got it? Because we have the formula, right? That is the formula. See, if you want the maximum hourly, you have to multiply annual average daily into 3. Sorry, that is annual daily. Let me change that formula. Average. Average daily. So if you want the average hourly, flow, you have to multiply again 1600 into 1.5. 2. So you'll get 16 into 2, 32 meter cube per day. So this is, then if you multiply 3200 into 1.5, you will get 4800. That is your maximum hourly. So average daily to average hourly is 2. Average hourly to our maximum hourly is another 1.5, that is 3. You got it? Yeah. Next one is, so they are given. So you have any doubt in the above question? Is it clear? Is it clear or can I explain again? Hello?
Clear, sir. Yes, sir. Clear.
Yeah, yes, let me move on. Yeah. So the second question they are given is the average domestic wastewater flow. Wastewater flow they have given us 300 LPCD. The population they have given us 50,000. That is the seaward population. The sanitary sewer system for the city include 100 kilometers of 4 in-house sewers, 22 kilometers of 6 in-building sewers, 56 kilometers of 8 in-street laterals, and 15 kilometers of 12 in submains and 12 kilometers of 8 in mains. So these are all sewer lines. So totally this many sewer lines are there, and one sewer line, one in-house sewer line is 100 kilometer. So 4 in-house sewer lines 400 kilometer. If you multiply everything, you will get the total sewer lines kilometers. Yes, what they are asking, estimate the infiltration flow rate. So how to find the infiltration flow rate? We have different table, right? If you know the area or if hectares, or if you know the kilometer of sewer lines, or if you know the manhole numbers, you can take from average from the table and you can multiply. So here they have given the kilometer of sewer line, and they have given the value also. Right? See, 1250 liters of infiltration per day per kilometer of sewer line. So I know the total kilometer. How many total kilometer? 100 into 4. Sorry, this is a mistake. Not 1000. 100 into 4. 22 into 6. 56 into 8. 15 into 12. And 12 into 18 will give me total kilometers. That is 4856 kilometers. And per kilometer, 1250 liters per day. So totally 6070 liters. I mean, I have converted 1000 liters into meter cube. 6070 meter cube per day. Got it? They are asking what is the average daily and peak hourly. So if you want average daily, you can take 6070 infiltration rate and its percentage of average daily. So first I need to know the average daily. Average daily is 300 LPCD into 50,000 population. I'm getting every day 15,000 meter cube per day. And if you take the ratio of this two, I will get 0.4 or 40%. Average hourly is I have to multiply 1.5 into average daily. Then it is 22500 meter cube per day. That will give you 27%. What is the formula? You can check back. Please. Average, yeah. Maximum day. Average daily. Yeah, maximum daily if you want to. Maximum daily into maximum hourly on the 1.5. Yeah, that is correct. So this is the answer. You got it? So this is all about the lecture point. We'll also solve some of the old assignment problems so that you can solve the this week assignment problems. So the deadline for every week assignments is Wednesday after 12 p.m. 12 noon. So you have to clear the assignment for every Wednesday. So this week, first week they have extended up to this week Wednesday. So please answer all the assignments. If you want to get the certificate, you have to register for the exam and you have to get the assignment score also. So that's what we have seen in the last class, how much the weightage is taken. You can also refer in the website about course. You can refer this. Okay. So if you have any doubt, you can ask. Otherwise, I will go to the problem solving session. So you can you can post the answer in the chat box. I'll read the question. So today we are having around 40 questions. So we will wind up soon. First question is the factors considering for estimating.
Hello, sir.
Yeah.
Sorry to disturb you,
Yeah, please.
but may we know the pattern of the question will be asked on the exam, final exam.
Pattern.
Pattern, sir. Pattern, technique, method. What type of the question will be asked in the
No, what
final
we are
exam?
solving in our assignment, same pattern only that will be there in our final exam also.
Okay, thank you, sir.
Yeah. So mostly it will be numerical. Everything will be numerical, or one or two will be some. Sorry, mostly it will be multiple choice. One or two will be numericals. That also very easy to solve. If you practice all the assignment problem, that will be very easier. So assignment problem will be simple. Like I will give you a consolidated formula sheet if I can. Maybe I will upload before the end of the week. That also you can follow by consolidating all the problem equations or formulas. That also I will give you upload in the Google folder. That also you can follow.
Sir, this question, may we get the question and answer in the Google Drive folder? Sir,
Yeah, that also I have uploaded last week's one.
basically we are working people. Today I am getting time because today is my next night shift. Every week it is not possible, so I am
I understood. I understood.
request.
Actually, I have uploaded along with the answer in the Google Drive. Last week also you can check. That also I have uploaded. Yeah.
Okay, thank you, sir.
Yeah. Or else the recording also will be there in YouTube. Link also will be uploaded. You can see the recording anytime if you
Okay,
contacted
sir,
with
thank
the
you.
link. Yeah. So let me read the question. Please post the answer in the chat box. A, B, C, D like that. The factor considering for estimating the quantity of municipal wastewater generated from the city include. So what are the factor we have discussed? Per capita waste consumption, population of the city, ratio of water usage to wastewater generation, all the above. So let me take the pen. Yeah. So per capita is required and population is required. Ratio of water usage to wastewater, that is the peak factor. Or 80% of the water consumed is wastewater. Like that, some value we are taking, right? So that is ratio also required. So all of this is correct. Yeah. So here you can see These are the estimation steps. We need the design period, design population, per capita, peak flow, that is a factor, additional inflow, cumulative design flow. These are all the factors we need to consider for designing a sewer, right? Yeah, thanks for the answer. So we'll move on to the second question. In addition to municipal wastewater, which of these are supposed to be carried by the combined sewers? So we have two systems of sewers. One is combined, another one is separate. So in combined, along with the sewage, what is the other thing that is going to be taken care? Stormwater runoff, industrial effluent, agricultural runoff, all of this. Already sewage covers three things: municipal, industrial, agricultural. Municipal covers household, commercial, institutional. So what is the one else? Stormwater. Stormwater will be taken care along with the sewage is called a combined sewer. If both are considered in a separate system, then it is called a separate sewer. So stormwater system is runoff is correct. Yeah, you got it. That is called the sewage is other name of sewage is called dry weather flow. Only in dry weather, what is the flow? That is called sewage flow. So other name of sewage is dry weather flow, DWF. Alright. Okay. Let's move on to the third question. Match the population forecasting approaches. We have discussed 10 population forecasting approaches, right? Which is suitable for which city? Arithmetic increase method, geometric increase, incremental increase. A is percentage growth of the population is constant. Sorry, they are asking about the principle behind arithmetic increase method, and the percentage growth of the population is constant. Population growth is progressively increasing or decreasing. The population increases a constant rate. So what we discussed in arithmetic, the population increases constant rate. That is called arithmetic. In geometric, the population is increasing in an exponential way. So the percentage growth is constant. Is geometric. What is an incremental increase? The increase may be increasing or decreasing. So there is a decrease in the increase. There is an increase in the increase. So anyway the population is going to increase, but the rate may increase or decrease. That is called incremental increase. That's why we are also considering the subtractor or addition in the increase. That is the third column, right? So arithmetic increase method is population increasing as a constant rate. Geometric increase method is, so 1 ka C. Geometric increase method, the percentage growth is constant. So A. Incremental increase, population growth may be increasing or decreasing. So B. C, A, B. Can you correct the answer? Answer B is correct. Yeah. Why? Okay, maybe people have confused with A and C. Okay. So please correct the answer. B is correct. So you can also see here. Arithmetic increase for developed places, geometric increase for rapidly developing phases, incremental increase for increasing or decreasing. Okay. So fourth question. Hope you are clear with the last question, right? So I will move on to the fourth question. In India, nearly about does percentage of sewage generated remains untreated due to lack of sewage treatment facility. This is what we have discussed in the last slide, right? 90% or 60%, 30%, 10%, which is not treated in India. No, which is not treated.
60%.
Nearly 62. That's what we have discussed in the slide, right? So 60 is correct. Not 30. 30 is treated. No. So 60% of the total sewage is untreated. So 60 is correct. So B is correct. Why C? B is correct. Yeah, please change. Hope it's clear, right? Here, for Indian condition, 62% of the total sewage is untreated due to lack of sewage treatment facility. Because we have only sewage treatment capacity for the above 40%. So this is lack of treatment capacity. That's why we are not handling this 60%. Yeah. Fifth question. Population carrying capacity limitation applies in population forecasting when using for a city which is having a population carrying capacity limitation, then which method we can use? Growth composition analysis method, incremental increase method, geometric increase method, logistic growth method. for a city, only 1 lakh population can be accommodated. Then initially it will slow down and it will start blooming. And after attaining this 1 lakh, it will follow a saturation curve. So the population carrying capacity of the city is limited. This type of system will followed in logistic growth method, right? So when the population carrying capacity of the answer is logistic growth. When the population carrying capacity is limited or applicable to the city with sufficient demographic data. So now here you can find some word. A limited space and economic opportunity. That is called logistic growth method. Okay. Yeah. Master plan method for population forecasting is mostly suitable for master plan method. Large and established city of moderate size and age, new cities being developed, only small clusters.
New
So,
city.
uh, so master plan is applicable when I am designing for a new city. I can divide the city. One is for commercial, one is for institutional, one is for industry, and some is for residential area. Then I can plan the city accordingly. So master plan population is after subtracting all the other areas, I can design only for this residential area. That is called the master plan method. This should be designed. This CEWA should be designed before while designing the city. So new cities, if it is designed, then it can be adopted, right? Or newly developing cities. Okay, so C is correct. Yeah. So master plan method, planned and regulated local bodies according to the master plan. Then we can use this. As per CPHEO, among the given commercial institutions, the expected generation of wastewater per user is lowest for. So we have a institutional additional wastewater, right? For different institutions, we have a different per capita wastewater requirement of based on CPHEO manual. So which institution have less wastewater generation? So office, hospital, restaurant, hotels. So hospital requires large amount of water for 100 beds and less than 100 beds. Restaurant also requires some. This is around 300, 350, 400 liter per day. Restaurants requires 100 or 75 liters per day. Hostel offices. Hostel also requires. We can see. Hostel requires 135 because again people are living. So living areas will require always 135 liters per day. That is the water we are supplying for any households and also for hostels. So offices requires lesser water requirement. So lesser wastewater generation also directly proportional because offices we are not staying. We are simply doing our work and only for the recreational purposes we need water. So offices will handle only 45 liters per capita per day per person. So as per CPHEO manual, officers requires in the given option, office requires lesser water. So other than what officers, you can see train, bus stations, aligning and boarding persons 15 LPCD. But normal public area 70 LPCD. Cinema theaters and all 15 LPCD only. In this question, if you see, this is a problem. Yeah, 1981, 91, 2001, 2011, 2021 populations are given. They are asking what is the average incremental increase. So directly they are asking an incremental increase. So we have to find first the difference, then difference in the difference. That is that average you have to take. That is the incremental increase, right? So please do with me. 1981, 1991, 2001, 2011, 2021. So every decadal increase they are giving in lakhs. So you can take in lakhs itself. 1.6, 1.92, 2.3, 2.76, 3.29. So this is the population on the given year. So what is the increase in the population? Increase in the population. So 1.6 minus 1.92, what is the rate? 1.92 minus 1. What is the increase alone? That alone we can calculate. So 0.32. Don't take positive or negative, just the increase I am asking. So here the increase is 1.92 minus 2.3. So 0.38. Like that, if you take the lakhs increase, So 0.32, they are writing in the horizontal way. 0.32, 0.38, 0.46, 0.53. Then if you divide this by this, you will get this value. This by this you will get the, sorry, I'm taking geometric method. They are asking incremental increase method. So increase in this increase. So 0.38 minus 0.3 to 0.06. 0.46 minus 0.38, 0.08. 0.53 minus 0.46, 0.07. Average of this, arithmetic average of this will be 0.07 lakhs per decade, or they are asking in without lakhs, you can multiply with 1 lakh, you will get 7,000 per decade. That is the incremental increase. Hope you all understand. The answer is B. Oh, you have taken 0.32, 0.38, 0.46, 0.53. Okay. Ma'am, you are talking about maybe you are talking about 42250 as average of this, but that is arithmetic average. They are not asking arithmetic average. They are asking incremental increase average. So here the answer what you are saying is correct. 0.44225 per decade. That is correct. What you said is correct. But the question is they are asking for incremental increase. So please change the answer as B. Right? So you have to take difference in this increase and take the average. That is incremental increase. This is what you have to take as I in the formula. Yes. Second, ninth question. Which of the following uses do not contribute sewage flow? All are okay with this question? Can I move on?
Yes, sir.
Yeah. Which of the following uses do not contribute sewage to the sewer lines? Infiltration from sewers, water used from private water supplies, water used for gardening and horticulture, all of this.
See, sir. Water used in garden.
Got it. So they are asking to not contribute. So infiltration of sewer will add the sewage. Water from private supply will add, but water used for gardening will be subtracted. So that will not contributed to my sewage. So they are asking what is not contributed to my sewage. So the answer is C. Right? Because this is a loss which is not entering the sewer system, like gardening, horticulture, air coolers, sprinklers, sprinkling over the roads, or any leakage in the distribution line or the household connection. That are all leakages that will not contribute to my sewage system. You got it? Yeah. Okay. So the answer is C. So 10th question, this is a two statement. Identify the correct statement regarding the peak factor. The peak factor is used to estimate the maximum flow for the sewer design. Second statement, peak factor typically increased with the increase in the population of the city. So can you guess which is correct and which is incorrect? The peak factor is used to estimate maximum flow for the sewage. That is correct, right? So we know the quantity of wastewater. If we multiply with the peak factor like 2 or 1.5, we can get the peak value or maximum flow. That is correct. The first statement is correct. What is the second statement? Peak factor increase with the increase in the population. Is it correct?
No.
Why?
Because it do not depends on the number of population.
No, it depends on the population, but it decreases with the increase in the population. Because if you have 10,000 people in a city, the peak factor will be 2. Uh, because we know 10,000 people, they may have different characteristics. They will use the different quantity of water. So average we have to multiply with 2. But if I have 10 lakh population in a city, so if I take average of this 10 lakh, my average will be nearly equal to my maximum flow. So my peak factor will be reduced like 1.1 or 1.2, right? So peak factor have direct impact on the population. So when the population, it's like a population of a system. So if you have a huge population in a set of data, my average will be nearly equal to the actual value, right? That's the thing. So if you roll the dice 100 times, the probability of getting one will be increasing, right? So if I throw the dice only one time, my factor will be very high. I mean, probability will be very less. So I have to multiply with the huge factor. That's the concept here. So peak factor typically decrease with the increase in the population. So this statement is incorrect. So 1 is correct, 2 is incorrect. Yeah.
Okay.
Because huge population, if I take the average, that is nearly equal to the maximum. So this is the thumb rule. If you take the maximum daily, sorry, this peak factor. See, if I increase the population, the peak factor is decreasing. If it is less than 20,000, the peak factor is increasing. But if it is above 7.5 lakhs, the peak factor is increasing. Sir, can you? Okay. So 11th question. So this is the given data. Based on this, they are asking 5 questions. So current population of a city, 2024 population they have given 14.6 lakhs. From the historical trend, the average population increase per decade was 2.1 lakh. Average population increase per decade. So arithmetic average increase they are given. It's not a percentage or not incremental. So simply the arithmetic average they have given us 2.1 lakh per decade. Average incremental increase they given us 0.4, that is I value. And then decadal percentage growth also they have given 24.5. Based on the information, we need to calculate first the arithmetic increase method we have to use and calculate the population or forecast the population of 2050. So 2024 to 2050, how many decades are there? 24 to 34, 44, 54, sorry, 2.6. 2.6 decades is the t value, right? So simply multiply with the 2.1 lakh. That is the arithmetic value, right? So 2.6 into 2.1, that is my increase. Add with 14.6, I can get the 2050 population. Today's population is 14.6 lakhs plus 2.1 into 2.6. Let me go to the next slide. P 2024, that is the current population. I need population of 2050, current population plus every decadal population increases to 2.1. How many decades I need? 2.6. So if you calculate, you will get 20.06. Are you getting? So the answer is 20.06. Are you getting this?
Yes, sir.
Yeah. So let me move on to the next one. Forecasted population of 2050 using geometrical increase method. So what is the formula? P at a time t, if we want, today's population into 1 plus k by 100. So 24.5 by 100 or 0.245 I can take into t. How many decades? 2024 to 2050, the same 2.6 decades. So if you multiply, what is the answer? By geometric increase method, this is 1 plus k, sorry, t. 1 plus kt, not here, here. So answer is 1 plus k power t. 1 plus 0.245 power 2.6 into 14.6. So answer is 25.81 lakhs. Right, this is the geometric increase method. The third question is incremental increase method. So how to find the incremental increase method? Same like arithmetic increase method. Pt equal to p naught into kt. Simply you multiply k into t. Every year's increases 2.1. That we are to multiply anyway. Plus there is a increase of 0.4 lakh per decade in the increase. So that also we have to take into account. So the formula is t into t plus 1 by 2 into I. So 2.6 into 3.6 by 2, t plus 1 by 2 into I, 0.4 lakhs per decade is increment in the increase. So this also we have to add with our arithmetic increase value. So the answer is 21.932 lakhs. Are you getting this?
Yes, sir.
So please understand the arithmetic concept, geometric and incremental increase method. P naught into P naught plus every year what is the increase, and every decade what is the increase into number of decade. This is P naught into 1 plus k by 100 power how many decades. This is simply like arithmetic. Again we have to add how much increase in the increase. So t into t plus 1 by 2 into I. So these three formulas anyway you have to remember. Yeah. 14th question. And these two formulas again you have to remember. Maximum to average to maximum daily to maximum hourly. These two formulas 1.5, 2 these are the two factors. So the average water demand is 360 mld. Out of this, 85% of the water used is received as sewage. So 360 mld is water supply. Out of this, 85%, so 0.85 is considered as a sewage. So this is the total sewage wastewater generated, right? So this is average daily wastewater. They are asking, assuming daily and hourly peak factors 2 and 1.5, answer the following. What is the maximum daily? So if this average daily is 360 into 0.8. We are getting 288. Out of this 288, this is the average daily. So we need maximum daily. What is average to maximum factor? 2. 2 is the daily factor. So if you multiply 288 into 2, maximum daily. Assuming daily and hourly peak factor as 2 and 1.5, what is the maximum daily flow of the sewage from the city? And average 0.85. Sorry, 360 into 0.8. 0.85. Yeah, 0.85. 360 into 0.85. 306. It's not 288. 306. Then if you multiply 306 into 2, you will get 612. Then they are asking what is the peak hourly. Then you have to calculate the peak hourly equal to average hourly into 1.5. So or else you can directly take 3 with the daily average. So this 2 you can use. So what is the daily average? I have already calculated as 306. 306 into 3, 918. That is the answer. 918 mld. But they are asking in meter cube per hour. So million liters you can million is 10 power 6. 918 10 power 6 liters per day. So liters to meter cube is 1000 liters is 1 meter cube. So you can divide by 1000. So 6 will become 3. So days you can convert to hour by dividing with 24 hours. So 918 into 1000 divided by 24. So the answer is 38250. You got it? So simple conversion, mld to meter cube per hour conversion. We need to know million is 10 power 6 and 1000 liters is 1 meter cube. And hours, a day to hour, you know, 24 hours in a day. Simply you can. If you want meter cube per second, again multiply with 60 into 60. So this will come with the denominator. 24 into 60 into 60, you will get meter cube per second. Right? So that is the conversion factors. Okay. So another questions like 2021 July assignment problems. Which of the following parameter is not used to quantify the municipal wastewater from a city? Total population of the town, per capita wastewater demand, or per capita water demand, percentage of utilized water reaching the sewer, stormwater received in the city. Total population of the city is required. Per capita required. Percentage of utilized wastewater reaching the sewer is required. Stormwater received in the city is not required in quantifying the municipal wastewater, right? Which is not used, they are asking. Stormwater received is not required. So they are asking which is not used to quantify, because that is not required in a normal sewer system. If you want a combined sewer system, then you need to know the stormwater received in the city. Yeah. So the answer is stormwater received in a city. See again the factors considering. Stormwater will not be here. Maybe some additional flow will come as a infiltration, not total stormwater. Yeah. So the second question is the population of a planned city need to be forecasted for 50 years. Okay. So you need to calculate for 50 years. Which of the following method will be generally result in highest design population? You can calculate by using arithmetic, geometric, incremental, or any method. Which method will give you highest value? Because arithmetic will give you a underestimate value.
Yeah. Incremental, I think.
No, geometric will give you overestimated. Incremental will give you the optimum value in between these two.
Okay, geometry.
Yeah, okay. So because we have found right in the example also, today's population is 4,000, but what we have calculated after 20 years, arithmetic given 9,500, but geometric given 1,50,000. But if you find with incremental increase, you will find the average value of 45,000 or something. So that's why we have shifted from each method. So based on which city, we can use which method to adopt. So highest design population will be always given by geometric increase method. That is a overestimate actually. But for a developing city, that is better. Yeah. See, relatively new city with unlimited scope of expansion gives a too large results. But arithmetic increase method will give you too small results. Okay. So the third question, master plan method of a population estimation is based on master plan method, same master plan method, population density and the zone size, annual birth or death rate and migration rate, growth rate characteristics of a living being within limited space and economic constraint, ratio of local to national population in the past few decades. If you know the different zones and if you know the population density of a residential zone, zone 1, zone 2, zone 3, you can find this is called a master plan, right? So population density and zone size are required for master plan method. Annual birth and death rate and migration rates are required for which method? We going to go to PPT. Yeah, growth composition analysis method or demographic method. We need the birth rate, death rate, and migration rate, right? Another method of master plan method is itself zoning method only. Zoning method of population forecasting. So whenever there is a zone size and population density, that can be used in the master plan method. Annual birth and death rates are required for demographic method. Growth rate characteristics of a living being within the limited space means that is a logistic growth method because we have a limited constraint. Then logistic method. Ratio of local to national population. Then it is a ratio method. Right. So the answer for here is master plan or zoning method. Here we need to know the zoning size and population density. Right. Okay. For a design of a sewer, estimates of per capita sewage generation is usually based on per capita is based on design population, design period, recommended water use and water generation pattern, wear and tear of the sewers. Per capita sewage generation is based on how much a person is generating is based on how much the water he is using and how much the wastewater he is generating. I mean, per ton. Because some people may conserve the water or minimalistic usage of water may result in minimum wastewater generation. So the water use pattern will also gives you the wastewater generation pattern, right? So recommended water use and the wastewater generation pattern is the answer for this per capita sewage generation. even though the population is 1 lakh and each person is consuming only not the total of 135 liter, they are consuming only 90 liters per day, then it is same as 2 lakh 50,000 population consuming 135 liters, right? So even in a big city with less consumption, I can design a small sewer. That is the usage, behavioral change we have to have. Yeah. Then, under which of the following population forecasting method, the maximum population of the city is limited by saturation population or carrying capacity? We have discussed now. City is limited by saturation population and carrying capacity. So the limited carrying capacity for, we have city having maximum value, then the city will try to reach exponentially. After reaching that, it will become saturation. That's a logistic growth method. Yeah, that is the logistic growth method. Population growth is progressively increasing or decreasing. So the population will increase, but the rate is decreasing. Again, there is an increase. Again, there is a decrease or increase and increase or decrease. This type of increase or decrease will happen in incremental increase method, arithmetic increase method, geometric increase method, growth composition analysis method. Yes, because the rate is increasing, here the rate is decreasing, here increasing, here the rate of increase is decreasing, again increasing. So there is an increase in the decrease in, there is an increase or decrease in the rate, then is a incremental increase method. The growth rate is progressively increasing or decreasing. Yeah. Can we move on? Yeah. Among the following commercial institution, the expected generation of wastewater is highest from. So we have a CPHEO 2012 manual for institutional or commercial institutions having different water consumption. So for day or school, colleges, hospital with bed, restaurants, cinema halls, which is having higher value of water consumption, so that they will have more wastewater generation. Yes, hospital with bed. So which is having lesser water consumption?
Option number 8, days, schools and colleges.
No. Schools and colleges will again have 25 LPCD. Cinema halls will have only 15 LPCD. Right? See? So here the answer highest is hospital. Let me check. Cinema halls and all 15. But you are saying about day schools and colleges 45. Right? So in the given option, I am asking cinema halls and concert are having lesser water consumption. Think about how much we are using. Here we are spending only 1 hour or 2 hours, but here we are spending maximum 8 hours or 12 hours. So consumption will be more. Yeah. The population recorded in 2011, 11121 are given. Use the arithmetic increase method and estimate the population. So I will not repeat the question. I will just read the concept. You can follow up, I guess. So we have the year and we have the population. For arithmetic mean, we need to know what is the difference in the population we have to get, and we have to get the average of this difference. So just PT equal to P0 into P0 plus number of decades is 2021, 31, 41, 51, 3 decades. 3 into this average. Okay, will give you the value, right? What is the answer? 11.7. See, after 3 decades. So 3 decades into per decade, there is a 1.5 lakh increase, arithmetic increase method. So you can easily calculate this. So for a city with the initial population of 8 lakhs, annual growth rate is 1.7%. So this is the geometric percentage they are giving. The estimated approximate population after 10 years. So 1 decade. So simply multiply. Present population is 8 into 1 plus 1.7%. So 0.017 power. How many decades? 10 years is 1 decade. So power 1. So 8 into 1.017 lakhs. So what is the population after 10 years or 1 decade? 8 into 1.017. 8.136 or 14. That is in lakhs. They are asking in thousand. So lakhs to thousand will be 100. So 814 is the answer, right? C is answer. Yeah, correct. C is correct. 814 is correct. So simply you need to know the time will be in decade. That is one trick. So that you please follow up. And which method, arithmetica, incremental, geometrica, you have to find and know the formula. You can easily crack, and the unit lakhs or thousands. And percentage, if they are giving in percentage, you can divide it by 100. If they are giving in value, you can directly substitute. Okay. So the 10th question is, the inflow in sewers may exceed the design flow due to the inflow in sewer may exceed the design flow. So what are the additional factors we can add? Sprinkling over the road, that will decrease. Household using private water supplies, that will increase. Water used in horticulture and landscapes, that will decrease the sewer. Because if I am supplying 100 liter, 10 liters will be used in the landscape. So only 90 will come. So that is decreasing. None of the above. So household using private water supply is increasing my design flow. Right. So answer is B. So additional account for additional inflows, unaccounted private water supply. Not only from private water supply, also from infiltration, also from institutions. So here the private water supply may increase. 11th question, the dry weather flow.
Sir, for the question number 10,
Yeah,
the sprinkling option number A, sprinkling over the roads, it may also generate the sir.
that will no. See, let me go to the PPT and tell you. We are talking about the additional inflows and outflows. So infiltration will increase, institution will increase, private water supply will increase. What are the losses? Here, see, I am supplying 100 liter per capita per day. So in your home there are 4 people. So I am supplying 400 liter per day to your home. But you are using 40 liters for road sprinkling. That will evaporate. That will not come to your sewer. Sewer is what you are generating in your household. You got it?
Okay, sir.
So that will be a loss. If I may deduct, I am supplying 400 to your household. So you may give me nearly 400 or 390 liters per day of sewage. But you are not generating. You are using 40 liters in your street. So again 350 only will come. So I have to subtract that 40 liters, right? So that are all losses. But you may take 10 liter from your borewell per day, and that will add again. So what are the additions? What are the subtractions we need to do? So inflows and outflows I have to calculate. That's the logic. So sprinkling over the road will evaporate, not add into our sewer lines. Yeah. 11th question, the dry weather flow of a community. What is the dry weather flow? The wastewater that is generating during dry weathers. So that is directly equal to your sewage. DWF is sewage of a community is usually less than the per capita consumption. Why? I am consuming 135 liters per day. That is the codal provision. I have to supply for residential area that 135 liter per capita per day. But what are the losses happening? Why the sewage is not 135 liter? Because there is a evaporation loss. There may be a ground seepage. There may be a sewer leakage, and all the above will contribute to the loss. So the per capita waste generation is around nearly 80% or 85% of the water that is given to the public. What can I give you the split up of that 135 liters? I'll show you. 1 second. Yes, basic requirement of water supply. So here if you see the basic requirement. See, this is the codal provision. According to code IS 1172, code for basic requirement of water supply, drainage and sanitation. This is our Indian code. So reformed in 2002. So here you can see water requirement for building and other residents. So for a building or for a household, building with the bathroom, I have to give 45 per head, and 135 is for boarding schools. This is what institution that we have discussed, and the split up for that 135 is given here. Right. Let me. This is factories. The split up. One second. Sorry for that. Yeah. Here you can see it's based on IS 1172. It's a code here only. And let me check and give you where the split up is given. For consumption, for a lower income group or higher income group, we have a system. For a system with a flushing, that is a higher income group. For a system with small Indian cities or towns with low income group colonies, drinking we are using 5 liters per day, cooking 5 liters per capita, I'm saying, per person. So 55 liters for bathing, that is 1 bucket or 1.5 bucket. Washing clothes, we are using 20 liters. Washing utensils, we are taking 10 liters. Residence washing, that is the floor washing, we are taking 10 liters. For higher income group, they are adding another 15 liters for gardens, but we are not having gardens in the low income group. And flushing toilets, we are using 30 liters. If there is a flushing system, this is by buckets, this is by flushing system, again another 15 liters are extra. If you add all this, that will give you 135 liter per capita per day. That is the average value domestic water demand given in the IS code, that is by the CPCB recommended value. So every household we are supplying 135 liter per capita per day, but we are not getting the same 135 liters wastewater. About 80 to 85% of the supplied water is coming out as wastewater. You got it. The loss may be due to evaporation loss, ground seepage or sewer leakage, or due to some consumption. Yeah. Hope you are clear. And 12th question, identify the correct statement concerning flow estimation in the sewer design. The peak factor of a community type typically decreases with the increase in the population. Peak factor of a community decreases with the increase in the population. This is correct or not? And then the minimum design flow in a sewer may vary from 1/3 to 1/2 of the average flow. And then the third one, the maximum hourly flow is equal to 1/3 of the annual average flow. Maximum hourly. Maximum daily equal to 1.5 times of maximum, average hourly. Maximum hourly equal to daily 3 times of maximum average daily. So here they are saying maximum hourly is equal to 1/3 of annual average. That is wrong. 3 times, not 1/3 into 3. It's not 1/3. So this option is wrong. Peak factor of a community decreases with the increase in the population is correct. Minimum design flow is 1/3 to 1/4. That is also correct. So both A and B is correct. So see here, the minimum flow may vary from 1/3 to 1/2 of the average flow, and the peak factor decreases with increase in the population, and the maximum hourly flow is 3 times of the average daily flow, not 1/3. So please remember this formula, that will be helpful. So in water supply also we have to know. Point will be 2, one is the peak factor will be 2. Typically, the peak factor of a community does not depends on dry weather flow, population density, site topography, supply hours. Population density is required, right? Anyway, 10,000 or 20,000 population, that we need to know. Site topography, supply hours we need to know anyway, right? Because peak factor may vary with 6 to 8 hours, 8 in the morning and 6 to 8 in the evening, so that is required. Site topography or dry weather flow. I am also confused. Dry weather flow. So that is a sewage generated. So the peak factor is not based on the sewage. Site also it will get vary, right? So site, which district, which city it's going to be followed. So it will vary along again with the what we say metro cities or not. So dry weather flow is, if you are generating 135 LPCD or 200 LPCD, that will not affect your peak factor. So you can see the hour it will vary, season it will vary, and the peak factor also depends on topography, population density, site, hours, but not on the sewage that is generated. So if I have 135 LPCD, I have to multiply with the same factor. If it is 200 LPCD also, I have to multiply with the peak factor. It's not based on the how much wastewater generated. It's based on whom the people who, how many people are generating. It's based on the topography. It's based on the time. So peak factor depends on density of the population, topography, and site and hour of supply. Yeah. If the average daily consumption of a town is 1.2 lakh meter cube, the peak hourly demand is, average daily is given, peak hourly is average daily into 3. So 12000 meter cube per day is given into 3, and we have to divide it by convert it into hours. So divide it by 24 into 60 into 60. So 12000 into 3 divided by 60 divided by 60 divided by 24. So we are getting the meter cube 00 average daily consumption. So, okay, sorry. This is not about wastewater. This is about water consumption. Average daily consumption they are given, peak hourly demand they are asking. So, think about this formula. This formula you can remember, but they may or may not be asked for water supply, not the wastewater generated. Maximum daily demand is 1.8 times of average daily. Maximum hourly is 2.7 times of average daily. So, they given 1,20,000 and they are asking the peak. So, peak will be 2.7 times, so not 3 times, that is for wastewater. So 2.7 times of meter cube per hour. If you divide, that will be get 13,500. Yeah, it's not second, it's hour. So the answer is 13,500. 12,000 divided by 34. Yeah, what you have calculated 15,000 is correct for wastewater, but that you have multiplied with 3, I guess. But you have to multiply with the 2.7 because it's the water supply, daily water consumption and peak hourly demand for consumption they are asking. It's not daily consumption, daily sewage generation and not hourly sewage generation, right? 15,000 is correct for sewage. 2.7 is correct for water consumption, water supply. Yeah, please correct it. Yeah. So the last question, determine, no, we have some more questions. Yeah, determine the approximate quantity of wastewater generated from a city with the total daily water consumption as 165 LPCD. If the conversion rate of water to wastewater is 85%, see, they are given water consumption and wastewater conversion. So 165 LPCD is converted into wastewater as 0.85. Then the total population of the city is 16,500. What is the approximate quantity of wastewater generated? So per capita is per person is generating 165. Then how much 1,65,000 population is generating? So multiply everything, you will get in liter per day. But I need in million liters. So just multiply everything 165,000 into 165 into 0.85. You will get a big number divided by 10.6, 10 power 6, because we have to convert it into million. So the answer is 23. Are you getting 23.14 something? Yeah, 23.14. That is, if you convert liters to million, then you will get this. So some more 10 questions you can simply answer. That is 2020's July question paper. So estimate the agricultural runoff. Estimation of agricultural runoff depends on type of crop and cropping pattern, precipitation, irrigation supply, all the above. I'll simply rush through in 5 minutes. Like agricultural runoff depends on type of crop, cropping pattern, precipitation, irrigation supplies. Yeah, correct. So quantity of runoff depends on crop, cropping pattern, irrigation supply. But industries depends on industries type of industry and production capacity. But municipalities depends on number of person, wastewater using patterns. Yeah. Combined sewers are designed to carry two types. One is municipal wastewater, that is a sewage. Other one is combined sewers. Yeah. Stormwater plus municipal wastewater. So A is correct. That is the combined sewer. That's correct. So third question, which of the following are possible consequences of incorrect estimation of quantity of sewage? If you are not estimating the quantity of sewage correctly, then what is your consequence? Uneconomical sewer system, hydraulically inefficient sewer system, inadequate design of sewer system, all the above. So you'll face all this consequence because your money will not be economical and hydraulically inefficient. We do not carry full and inadequate design. Yeah. So all the above. That is correct. That are the consequences. If you overestimate, that is uneconomical. If you underestimate, that is inadequate design and hydraulically inefficient. The design period of a sewer system is chosen based on design period. We have different component and different design periods, right? So design estimated population or area of the city, useful life of the sewer system components, all the above. No. Design period of a sewer. Design period of a sewer. We have a table, right? For a pump 15 years, for a land 30 years, for a disposal facility 30 years, for a sewer line again 50 years. So these are all components. So useful life of a sewer system component is based on this. See, component is design period is based on the component. So the answer is useful life of the design systems. It's not based on the population. Based on the design period only, we are estimating the population. Population is not coming in the first hand, and it's also not based on the area of the city. Right? Please correct on yourself. Design period is based on the component what we are designing. Yes. For that design period only, we have to forecast the population. If arithmetic increase method is used for population estimation of a small or comparatively new cities, it's generally expected to give arithmetic increase method. Will give you a correct estimation or highest population estimate or lowest population estimate or none of the above. Geometric estimation will give you the highest population. Incremental will give you the optimum population estimate. Arithmetic will give you the lower population estimate. Yeah, giving you the lower population estimate. And percentage growth rate is assumed to be constant for which of the following? Growth rate is constant for arithmetic. Percentage growth rate is constant for geometric. So answer is geometric increase. Right? So percentage growth is constant for geometric increase method. Then which of the following is not true regarding master plan method? Not true. City is divided into various zones such as residence, commercial and industry. That is correct. Population is estimated based on the zone size and planned population densities. That is also correct. It is very easy to access the design population precisely. Nowhere we can find the design population precisely. It is suitable for all type of cities, old as well as new cities. Wait, sorry. This is wrong because master plan is used only when a new city is going to be developed. Here we are finding the population precisely for a specific zone. So that's what they have given. Very easy to access the design population precisely. That is correct. So this option is wrong. It is not suitable for all cities. It is suitable for well planned city having a local bodies are having a master plan. Then what is the difference between simple graphical and comparative graphical method? Simple graphical method is approximate method, whereas comparative graphical method is accurate method. No. Comparative graphical method requires data from minimum 3 cities, whereas simple graphical method requires population data only 2 cities. That is also wrong. Comparative graphical method is always more accurate than simple graphical method. That is also wrong. Unlike comparative graphical method, simple graphical method does not record population trend from any other characteristic similar data. Correct. Because simple graphical method, we have the trend and we are just simply extending the trend. But in comparative graphical method, we need to know similar cities growth rate, and our cities growth rate we are simply extending similar to that cities. So D is correct. Right? This is also correct. Comparative graphical requires data from minimum 3 cities is correct. But this is wrong. So this whole option is wrong. Simple is extended smoothly curve. Comparative is cities having condition and similar characteristics. So we need to have at least 3 cities. All of the water supplied from the municipal users does not reach sewer lines after use. All of the water supplied for municipal use does not reach the sewer lines after use due to, we have already seen, sewer lines cannot accommodate sewage generated. No. There will be some infiltration from the sewer reduces the flow in the sewer lines. Water used in the lawns and gardens, air cooler, sprinklers over the road typically do not generate sewage to reach the sewer lines. Sewer line cannot accommodate sewage generated from total supply. That is wrong. Infiltration from the sewers increase. It will not reduce. It will increase. So this is the added value. So this is also wrong. So water used in the lawn do not generate the sewage. So that is correct. Option B is correct. Can you read again? Sewer line cannot accommodate. That is wrong. Infiltration will add. It will not reduce the sewage flow. Only lawns, garden sprinklers, road sprinkling will reduce the sewage. So that's why water supplied is not equal to the water reaching the sewer lines. So option B is correct. So that is considered in the loss. In addition to the estimated municipal sewage flow, additional inflow to the sewer can be resulted from estimated municipal flow, additional inflow. There are 3 additional inflows. One is from the commercial institution, one is from the unaccounted private water supply, and one is from the small industry discharging effluent to the public sewers. So all 3 will contribute to additional inflow to my sewer. So all of this is correct. Right? These are all additions. What are the reductions? This type of lawns, sprinklings. Yeah. As per CPHEO, the infiltration inflow into the sewer line can be considered maximum up to dash percentage of the design value of the sewer. This is given in one of the slide. Can you know the value? How much infiltration we have to? Because infiltration cannot be precisely calculated. So there is a percentage of percentage value given in the CPHEO. It's not 20, it's around 10%. So you can see here, as per CPHEO 12 recommends take 10% of design value of the sewage flow as infiltration. So if I know 135 is consumed and coming out is 120 as wastewater, out of that 10% is 12 liter I can add as infiltration. Okay, so I can design the sewer. Yeah. So this the city having 5 lakh population, average increase is 1.1 lakh, geometric mean growth is 0.2. Which method will give you the highest estimate? Just for 3 decades. Whatever the decade, usually geometric increase method will give you the increase, or you can also calculate. The value will be higher for, see, 5 plus 1.13 is 8.3. 5 into 1.2 power 3 is 8.64. Always geometric will give you the increase overestimated value. So this is again, how to calculate with incremental increase method. Just give year, population, the increase, that is the difference between this. Incremental increase is difference between this, and average of this will give you the I value. Simple arithmetic formula plus incremental increase will give you the total incremental increase value. Again, the average and peak value. Average annual daily is given. Maximum hourly factor is given. What is the maximum hourly they are asking? Factor is 2 and 1.5. So if you multiply 2 and 1.5, that is 3. So maximum hourly will be 3 into 60. That is 180 mld. If you convert 180 mld into meter cube per hour, how to convert? 10 power 6 by 3 will 10 power 6 will be liter per day, and 10 power 3 will be meter cube per day, and again day to hour will be 24. So 180 into 10 power 3 divided by 24 will give you 7500 meter cube per hour. The answer is correct, right? Totally 2 into 1.5 will give you the maximum hourly 3. So the last question, they given all the master plan of a city. Road takes 20, garden takes 10%, school takes 2%, market takes 3%. So what is the remaining? 20, 30, 32, 35% is taken for other amenities. So what is remaining? 65% is for my residential area or population growth. In that 65% of the area, 10 meters square is required for per person, and FSI is 0.6. FSI means in a given area only 0.6 is occupied by the building and the other area is for free area. So that is called floor. What is FSI?
Floor space index.
Yeah, floor space index. Floor space index or floor area ratio, FAR. So in a given, if you see, if you are buying 1 acre of land, you are not building the whole building for 1 acre. Only 0.8 acres will be used for building construction, others will be for land or something. So that is a floor space index. So I am having 65% out of this 0.6. So into 0.6 into 10 meter square per person. So how you will get whole value. So 65 into 0.6 into 10. 390 will be my density per hectare, right? And the answer is 10. Same, the example in the CPHO manual, if you follow, you will get the number of person or density per hectare. That is 390 per hectare. So that's all about this week. So if you have any doubt, you can post it in the chat box, or you can unmute and you can ask, or if you don't have any question, you can leave the meet. Thank you so much for joining. The recordings will be uploaded by tonight itself, and the next class will be next Monday 6 to 8
Thank you,
p.m.
sir.
Thanks for joining. Thank you all.
Thank you, Saran sir. Thank you.
Yeah, thank you. So if you need, if you have any question, you can also ask in the Q&A section of SWAYAM portal. That also I will periodically I'm answering that. Thank you. If you don't have any question, you can leave the meet. Thank you all. Don't forget to give the assignment by Wednesday itself. Thank you all. If you don't have any question, let me end the meet. Thank you all.